Chemical bonding. What is chemical bonding, students? In 8th standard, you had, I think, 8th standard or 9th foundation only. What is chemical bonding? Anyone? Interaction between two atoms. Okay. Why atoms need interaction? Sandra? Interaction between two atoms to reach octet configuration. Do you think in all the cases octet configuration are they getting octet configuration? Suppose H2 molecule, if I take, yes, to be stable in two ways. Sometimes they may or may not get octet configuration. H2 molecule, if you take, after formation of molecule, H2 molecule, hydrogen, two hydrogen atoms, they combine and they form H2 molecule. There 1s2 configuration we get. Yeah, sometimes octet configuration, but not every time. So H2 molecule case, duplet configuration. Nearest noble gas is helium. They get helium configuration. That is also stable only. Very good. So most of the atoms exist independently. So they combine with other atoms of same or different in order to get stability. Okay. So now chemical bonding, it is like force of attraction between two atoms, or sometimes in between ions also there must be some force of attraction between two atoms or ions together in a molecule is called chemical bonding. Right now, force of attraction between two atoms or ions. Force of attraction between two atoms or ions together in a molecule is called chemical bonding. It's called chemical bonding. H2. Here two hydrogen atoms are combining, forming H2. Next, even O2 also, O2. Two types of two forces of attractions are there, double bond will be formed. Next, what is the purpose of chemical bonding? Purpose of chemical. Dhanush, correct. One is to attain stability. To attain stability. Or to attain stable electronic configuration. Sandra, correct answer. Stable electronic configuration. Another purpose is to reduce energy or to minimize their energy. To reduce energy. To attain stable configuration, another one is to reduce energy. Stable configuration, you know, hydrogen atomic number 1, its electronic configuration is 1s1. One more hydrogen also same. So if they share, each hydrogen, if it shares one electron, like this it forms. Now these two electrons belongs to two hydrogen atoms. This hydrogen will get 1s2 configuration. Even this hydrogen gets 1s2 configuration. Nearest nucleus helium configuration. In that way, that is the reason I wrote stable configuration. I didn't mention octet configuration. It can be duplet, it can be octet. So better to keep stable configuration to attain stable configuration. First purpose. Second purpose, how they reduce energy, students? How they minimize energy, Sandra? How they reduce energy? Actually, this is not required. By forming molecules or compounds. While forming compounds and molecules, how they reduce energy, we'll see. See, students, there is a nucleus in each atom. When the two atoms comes close to each other, here each atom contains electrons also. When the two atoms approach each other, there are force of attractions between oppositely charged charges. There are repulsions between same charges. Like charges repel each other and opposite charges attract each other. Here, repulsion occurs between same charges. Between opposite charges, attractions occur. So, in this, if attractions dominate repulsions, if attractions dominate repulsion, then only chemical bond occurs. Attractions dominate repulsions, chemical bond occurs. Otherwise, it will not. So, anyway, attractions will be there, repulsions will be there. During the repulsions, both atoms lose energy. Both atoms lose energy. That is the reason. After forming molecule, they lose energy. So, chemical bonding is exothermic process. Formation of bond is exothermic process. Understood, students? While forming bonds, okay, students, because of repulsions, they lose energy. So, chemical bonding, formation of chemical bonding is a exothermic process. They lose energy. Now, hydrogen combine to form H2 molecule by the loss of energy. You know, stability is inversely proportional to energy. Yes or no, students? Stability is inversely proportional to energy. If I am energetic, I won't be stable to a particular position. Otherwise, you compare 9 years boy, 90 years grandpa. I am taking care of both people, even 9 years boy and 90 years grandpa. What Lewis dots represents which electrons? Sandra. Lewis dots represents all the electrons. Dhanush correct answer. Sandra correct answer. Valence electrons. Lewis dots represent valence electrons. Suppose here lithium has lithium atomic number 3. It has its electronic configuration 1s2, 2s1. It is having only one valence electron. So that one valence electron will write like this. So don't get confusion, students. Don't write 3 electrons. You have to write only one electron. Only valence electron we have to write. These dots represents number of valence electrons. valence electrons. Beryllium, if you take 2. Nitrogen, how many valence electrons, students? 5 valence electrons. Very good. 2, 3, 4, 5. If I take O2 molecule, O2 molecule, just molecular form I am taking. You know, O connecting with the double bond. This and all I will explain. Some already you know, I think this one, O2 formation and all. For each oxygen, how many electrons I have to give, students? How many dots I have to give? For each oxygen, 6. Sandra, isn't it? So according to you, 3, 3, 3, 3, 3, 3, 3. Isn't it? 4 we have to give. If it forms double bond, 4 we have to give because it has 6 valence electrons, right? In that 6 valence electron, 2 electrons already involved in the bond formation. 2 electrons involved in bond formation, right? Only 2 pairs will be there. Aishwarya, got it? So here also same thing. So from this, what we can tell, whenever the oxygen is connecting with the double bond, we have to give 2 lone pairs, means 4 electrons. If it is connecting with the single bond, 3 lone pairs you give. 3 lone pair, 3 pair of electrons you have to give. Now we'll go to the other molecule. Carbonate ion. For ions, how to represent these dots? Carbonate ion. Carbonate ion. So I'll write the structure of carbonate ion. Double bond O. 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 Because carbon valence is 4. Carbon valence is 4. O minus. O minus will write. Otherwise, let it be. Anyway, with electrons will represent. Here, from carbon, all 4 electrons involved in bond formation, isn't it? Carbon form 4 bonds, right? So now here, oxygen form 2 bonds, so 2 lone pairs. Here, single bond means 3 lone pairs. 1 pair shifted to oxygen. Like this. Over. Sulfate ion also you can write in the same way. You can give like this. Like this, you can represent Lewis. What is the correct representation of Lewis dot representation of sulfate ion, like that they are asking. Side heading ionic bond. Types of chemical bonds. First heading. First one is ionic bond. What is ionic bond, students? Name itself you can make out. What is ionic bond? What is ionic bond? Ionic bond means bond formed between 2 ions, right? Ions. So between oppositely charged ions, which type of force of attraction is there? Suppose XY is one ionic compound. In that X is cation, Y is anion. Which type of force of attraction exists between two oppositely charged ions? Yes, and the correct answer. Electrostatic force of attraction. Electrostatic force of attraction between oppositely charged ions. Which type of force? Electrostatic force of attraction. So we can define now. Electrostatic force of attraction between two oppositely charged ions is called ionic bond. Electrostatic is called ionic bond. Ionic bond. Here, example, formation of NaCl. Formation of NaCl. Formation of NaCl. See, students, if they ask you to write formation of NaCl in board examination +1, first take sodium one side, means cation one side, anion one side, or metal one side, non-metal one side. Its atomic number 11 and electronic configuration is 1s2, 2s2, 2p6, 3s1. So sodium has only one electron. Chlorine, if you see its atomic number 17 and electronic configuration is 2, 2s2, 2p6, 3s2, 3p5. 3p5. So here valence electrons 7. 1, 2, 3, 4, 5, 6, 7. Chlorine needs 1 electron to get octet configuration. Sodium needs 7 electrons to attain octet configuration. Getting 7 electron is very difficult. Suppose here what 2, 8, 1. If it lose this third shell electron, then in second shell it will get octet configuration. Otherwise, it has to gain 7 electrons. Gaining 7 electron is very difficult compared to losing 1 electron. So generally metals are having 1 or 2 or 3 valence electrons. They are ready to lose that 1 or 2 or 3 valence electrons. Gaining 7 electrons, 6 electrons, 5 electrons is difficult. So metals are electropositive. Now here already 7 electrons are there. No, gaining 1 electron is not difficult. So sodium transfer, by losing 1 electron, sodium will get stability. By gaining that 1 electron, chlorine also attains stability. Both are getting benefit. So after losing the 1 electron, sodium becomes Na plus. Cl will gain that electron and become Cl minus. Now Na plus C study, Cl minus C study. If you add these two, we'll get this equation. This way NaCl will form. NaCl will form. Sodium will get nearest noble gas neon configuration. Chlorine will get argon configuration. What is the electrovalency of this compound, students? Electrovalency of this compound. Electrovalency of the compound. Anyone? Electrovalency is nothing but number of electrons transferred between two ions. Number of electrons transferred between two ions. Now you tell me. Sandra, correct answer. Kripani, the correct answer. No? So here electrovalency is only one. Is equal to 1. Means only one electron is transferred. Same thing we can do for formation of magnesium chloride. Magnesium chloride. Magnesium atomic number 12. Shall I write direct configuration, student? 282. 282. Chlorine same. 287. Magnesium has 2 electrons excess than octet configuration. But one chlorine can gain only 1 electron. So magnesium needs 2 chlorines to transfer its 2 electrons. Okay. Now magnesium Lewis dot structure I'll write. 2 dots. Chlorine. Here one more chlorine. Also contains same number of electrons, 7. So here 2 chlorines are gaining 2 electrons. Magnesium is losing 2 electrons. So Mg2 plus 2 electrons. Right side electrons indicates they lost. Here 2 Cls are gaining 2 electrons. Mg plus 2Cl gives MgCl. MgCl. In this way, magnesium chloride formation take. Here, what is the electrovalency, students? And the correct answer. Anirudh, correct answer. Electrovalency is equal, Aishwarya, correct answer. Electrovalency is equal to 2. Hope you understood, students, how ionic bond formation takes place between two ions. Next, say heading, properties of ionic compounds. Properties of ionic compounds. Properties of ionic compounds. First one, property. State. Ionic compounds exist in which state, students? Ionic compounds exist in solid state. Very good. Most of the ionic compounds exist in solid state. Reason is, what is the reason why ionic compounds are existing in solid state? Very good. Arman, correct answer. Arman. Because of strong force of attraction. Sandra, correct answer. Strong force of attraction between positively charged ions. Very good. attraction. What about melting point and boiling point, students? High. Very good. If the force of attractions are high, if the constituent ions are attracted by strong forces of attractions, melting point and boiling points also must be high only. To break the constituent ions or to break the attractions, we have to use high energy. So they have high melting and boiling points. Solubility. Are they soluble in water or not? Why they are soluble in water? Why ionic compounds are soluble in water? Non-directional. Because you know opposite charges, no, they can attract any in any direction. Like this. There is no particular direction. Since it is opposite charges, no, they can attract in any direction, any way. If it is covalent bond, there is a direction, specific orientation. So it is non-directional. So theoretically, we can't say how these ions are arranged. Non-directional bond. Ionic bond is non-directional. Next, these are the properties of conductivity. I forgot to write mention the point. Conductivity. Are they good? Okay. Ionic conductivity. Yes, are non-correct answer. These are good conductors in aqueous or molten state only. Only. In solid state, they are not good conductor. They won't conduct electricity. Why? Only in aqueous.
Ions.
Here, ionic conductivity is due to the movement of ions. First, ions has to generate. No ions, they have to generate. Then only they can move towards opposite charge electrodes. They conduct electricity. Here, in the solid state, free ions not form. Electron transfer also will not take place. In aqueous or molten state, ions will be generated. Free ions will be generated. They can conduct electricity. They are good conductors or conduct electricity. Molten or aqueous state, aqueous medium. Next one, we are giving extra energy. C1, no. Yes, I'll tell you. Emma, positive charge. Here there are some electrons already. Electrons are there. Again, you are adding electron. Means negative charges are there. No, in inner electrons and outermost electrons. Again, you are adding electron. Between same charges, repulsions will be there. Yes or no? In shells there are electrons. Again you are adding electron. So between same charges, repulsions takes place. In that repulsions, atom lose some energy. That is the reason electron affinity is exothermic. Electron affinity is exothermic, but not in all cases. Means in all, only first electron affinity is exothermic. Exothermic. Got it, students? So energy is releasing while adding electron, I told. If more energy is releasing means more dense electron is adding. So anion will be generated easily. So the first factor is low ionization energy of cation. Energy of cation. Cation must have low ionization energy. Anion must have high electron affinity or electron gain enthalpy. And size wise, if you see, size of cation must be large. In case of anion, you don't make that statement because electron affinity, some variation, some exception is there. Chlorine has more electron affinity than fluorine. Sulfur has more electron affinity than fluorine, like oxygen. So better not to make size factor in case of anion. Generally, smaller the anion, higher will be the ionic character. If they give in examination, you follow that. I don't want to give here because electron affinity factor I included. No. Next, one more term I wanted to introduce. What is lattice energy? Lattice energy. What is lattice energy, students? See, students, NaCl. I'm considering one lattice. Yeah, I told you know there must be some force of attraction between these ions in this lattice. So to break this, we need to apply some energy. That after breaking, it will convert to gaseous state. Even chlorine also converted to gaseous state. But that whatever the energy we are using, that energy is called lattice energy. Energy is called lattice energy. What is lattice energy? Amount of energy required. Amount of energy required. If you want right now, amount of energy required to break. Amount of energy required to break 1 mole of ionic lattice. Actually, ionic means lattice only. Ionic compounds generally form lattice. Lattice into constituent ions in gaseous state. Constituent ions in gaseous state. Constituent ions in gaseous state. It's called lattice energy. In some books, they are giving like amount of energy released while forming 1 mole of ionic lattice from constituent ions. Their energy is releasing, here energy is required. For the formation, energy will be released. When they form, while forming lattice, energy will be released. While breaking, we need to apply, it is a reverse process, right? One process, if it is exothermic, reverse process is endothermic. In one process, energy is releasing means opposite process energy will be required. And law of conservation of energy you just follow. How much energy is releasing during the formation of particular compound, same amount of energy you have to utilize to break the molecule. Energy remain same. Okay. So you can also define with respect to formation or like this also. Now, lattice energy in inorganic chemistry plays major role, student, to decide the solubility, to decide the stability, to decide the strength of the compound. We should know the lattice energy and applications. First, means we have to know factors affecting lattice energy. See here, students, I am giving some compounds. You tell which is having more lattice energy. NaCl2, CsCl2. NaCl and CsCl, which is having more lattice energy, means which requires more energy to break. NaCl or CsCl, students? Sandra, why? Dhanush, why? You have nice coordination, I think. One student gave CsCl, another student gave NaCl. Obviously, anyone is correct. No? So larger ionization energy, if it is having larger ionization energy, how it is connected to lattice energy, tell me? Lower ionization energy. Yeah. If it is having lower ionization energy, you can unmute and speak instead of typing.
I thought it would have stronger forces of attraction because the cation is much larger and it would have lower ionization energy. So then because of that, then the lattice energy would increase because it would require more energy to break.
Yes, yes. Most of the students are thinking like this only and they are doing mistake. More ionic means it may not be more strong. LiCl is less ionic, but it is more strong. Emma, more strong is more ionic is different, more strong is different. CsCl is more ionic, but not so strong. Some people will have intention. Like I told some other marriages, they will before marriage they will have more intention. I want to marry. I want to marry. They like each other. Once after marriage, after 1 year or 2 years, start like DJ sounds will come from their home, fighting, so many things. They have more tendency for that. You don't think they are lifelong they maintain. No, not in all the cases, some exceptional cases, general cases I am telling. If they have more intention, they will be more stable. Like that, we can't say. Same thing. If they are more ionic, means tendency will be more, they form bond. They form bond. More tendency will be there. It may or may not be strong afterwards. Same thing here. Lattice energy and ionic nature we can't compare, Sandra. See, now in your class only I can make out. In the beginning, almost 10 members kept their videos on. After half an hour, that number came to 6. Roughly, I am telling the numbers, like that it decreased. At the end, only my video will be on. Okay. Slowly, we are losing interest. We are losing the concentration. I feel. Okay, please don't lose. NaCl. Lattice energy. Now I will give the factors. Purposefully, I asked that question because most of the students, there is a possibility of thinking more ionic, more strong, but lattice energy is different. Lattice energy is directly proportional to, I'll put side heading, factors affecting lattice energy. First one, size of lattice energy is directly inversely proportional to size of cation and it is also inversely proportional to Arman, correct answer. If the atom is small, bond length or this attractions will be strong. Next. So NaCl, CSCl if I take, which is having more lattice energy, NaCl. Anion size, anion is same. So cation size you check, Na size is smaller than cesium. Next one, next factor, charge on ion. Lattice energy is directly proportional to Na plus NaCl, MgCl2 if you take, which is having more lattice energy strengths? Sandra, correct answer. All the elements are non-metals only. In ammonium ion and chloride ion, ionic bonding. Sometimes they ask types of bonds present in NH4Cl, like that they may ask question. Covalent bond formed by sharing of electrons between two atoms. Equal contribution and mutual sharing of electrons. Equal contribution. While contributing equal number of electrons, they contribute, and while sharing equally, they share. Okay. Now, covalent bond formed between non-metals. Can you give any one example for covalent compound with metal and non-metal? Tanmay, in this, which is metal, which is non-metal in CH4? Carbon is metal. LiCl. LiCl. I will explain why it is having covalent character. First, we'll discuss these points. Simply, I asked. Of course, AlCl3 will consider in the maximum ionic character only. Covalent bond. We know the definition. Example, if you want, 2, 3, write F2 molecule formation. F2 molecule formation. Fluorine has 7 valence electrons. I'm not writing electronic configuration since you know. So each fluorine needs one electron. So they readily share only one electron. Like this fluorine molecule will form. Each fluorine has 3 lone pair of electrons. If you go for example 2, O2 molecule formation. Oxygen has 6 valence electrons. Oxygen needs two more electrons to get octet configuration. So each oxygen readily shares 2 electrons. If one atom readily shares 2 electrons, means double bond will form. One electron will form one bond with other atom. 2 electrons, if it shares 2 bonds, it will form. So oxygen here lone pair, lone pair, lone pair, lone pair. O2. N2. Nitrogen has 5 valence electrons, so it needs 3 more electrons to get octet configuration. So N triple bond N. These are all the examples of covalent bond with the single bond, double bond, and triple bond. Understood? So if any two atoms form multiple bonds, particular atoms if they form multiple bonds, in that only one is sigma bond, rest all are pi bonds. Do you know the difference between sigma and pi bond? What is sigma, what is pi bond, students? If you know, just briefly I'll give and I'll go to the next topic. Yeah, that's what. So most of the things in this you know very well. Most of these things you know very well. So little fast I am going. There's molecular orbital theory, Westport theory, that and all. I want to focus more for competitive. It is important. Okay, so this will finish little fast. And if you find anywhere difficult, if any students are I don't know, can you explain? I will explain. Though, you don't hesitate to ask. Next, properties of covalent compound, students. Properties of covalent compounds. Properties of covalent compounds. Tell me, students, here state in which state covalent compounds exist. Sandra, gaseous state. Graphite, is it covalent or ionic, Sandra? Covalent, right? Graphite, is it existing in gaseous state? No. Then bromine, Br2, it is a liquid, covalent. Okay, so covalent compounds can exist in all three states. All the three states. What about melting point and boiling point? Low comparatively ionic compounds. Some exceptions are there. Diamond and all, they have high boiling points due to their network structures. Next one, conductivity. Otherwise, right, except diamond. What about solubility, students? Are they soluble in water? Generally, they have less low solubilities in water. They are less soluble in water. That too less soluble. Why I am telling? Some polar compounds are there. Polar covalent bonds. Polar covalent bond HCl, H plus Cl minus. Such polar compounds can soluble in water. So compared to ionic compounds, these are less soluble. Directional property. Covalent bonds are directional, students. Particular overlap or that symmetry should be there, orientation should be proper. All those things are considered here. So this geometry we can define. 4 bonds, if it contains 4 bonds, how it is, 3 bonds, how it is, like that. Next one, conductivity. Are they good conductors or poor conductors, students? These are poor conductors. Except graphite, Santa, correct. Except graphite. This much. Next side heading, valence bond theory. Valence bond theory. It is the advanced theory compared to Lewis octet or Lewis dot structure with respect to Lewis dot C. They explain no with compared to that Lewis explanation. Valence bond theory is little developed one. In Lewis dot structure, what we learned only from which shell, a valence shell, how many electrons are sharing, how many bonds are forming, that and all we learned. Which subshell is participating, we don't know. And how they are interacting, we don't know. They didn't give that explanation. So in valence bond theory, how while forming bond, chemical bond, how atoms are approaching, how atomic orbitals are undergoing interaction, all those things they explained here. So according to valence bond theory, atomic orbitals of valence shell undergo overlapping. That also not all the orbitals. Orbitals which are having unpaired electrons. Orbitals which are having unpaired electrons undergo overlapping. So here they explain the chemical bond bonding with respect to overlapping. By taking overlapping concept, first, what is overlapping? What is overlapping? Overlapping is nothing but partial merging of atomic orbitals. Partial merging of atomic orbitals is nothing but overlapping. Partial merging of atomic orbitals is called overlapping. It's called overlapping. There are different types of overlappings based on the subshell or orbital involved in overlapping. E classified SS overlapping, SP overlapping, PP overlapping. S orbital of one atom is overlapping with S orbital of another atom. Then it is called SS overlapping. And it is called SS overlapping. Types of overlappings. Side heading SS overlapping. S orbital. What is the shape of S orbital, students? S orbital, yeah, you can. Shape of S orbital. You didn't see. Spherical. Shape of S orbital is spherical. So here, if it contains one unpaired electron, undergo overlapping. So while undergoing overlapping, electron spins will be anti-parallel to each other, students. Anti-parallel to each other. One, if it is having clockwise direction, another one will have anti-clockwise direction. So like this, after forming the bond, electrons will be arranged like this. This is SS overlapping. S orbital of one atom, another atom. SS overlapping. Example for this, H2. H2. Because hydrogen atomic number 1s1. Last electron is present in S orbital. So SS overlapping. Next one, SP overlapping. S orbital of one atom is overlapping with the above. S orbital. What is the shape of p orbital, students? Just now I did know that, you don't tell. What is the shape of p orbital? Srivani, correct answer. Shape of p orbital you don't know, students. Boys, you may be knowing this shape. I think you people are not going to gym. Bodybuilding you are not doing. Yes, Arman, correct answer. Dumbbell shape. Dumbbell shape, I told no, don't draw dumbbell exactly. Just imagine like this. Like this. This you have to hold dumbbell. Electrons will be shared like this. SP overlap. Dumbbell shape, I told no, don't draw like this. Okay, students. So in PU, one student do like this. Draw shapes of orbitals. Draw the shapes of all SPDF orbitals, SPD orbitals we asked. Dumbbell shape you know, so dumbbell only draw. If you saw a dumbbell. Okay, SP overlapping. Could you give one example for this overlapping, students? In one atom, s orbital electron should involve. In another, from another atom, p orbital electron should involve. Give one example. H2O. Okay. Srivani, correct answer HCl. Yes. HF, HCl. H2 also you can take, but it undergo hybridization. Okay, let it be. Overlapping is there now. H2S I'll write better. Problem is there with this. H2S. Let's say. PP overlapping. PP overlapping. Here PP overlapping again, it is two types. What are the two types, students? PP axial overlapping. You can also write end-to-end overlapping. Second one is PP lateral overlapping or sideways overlapping. Sideways overlapping. First one, see here, axial overlapping means p orbital, one end of this p orbital overlap. Here one electron, here one electron. This is axial overlapping. This overlapping is along the internuclear axis. Internuclear axis, if you take like this, along the axis. So it is end-to-end overlapping or axial overlapping. In this overlapping, always sigma bond will form. Sigma bond will be formed here. Axial overlap. Lateral overlapping. Sideways overlapping. P orbitals can also overlap like this. Like this. Or after the overlapping, like this. this. Sideways overlapping. Or you. Here, which type of bond will form, students? Pi bond. According to you, which bond is strong bond? Sigma bond or pi bond? Which is strong? Which bond is strong bond? No. No, Sandra, no, Prepanidi. Sigma bond is strong bond. Here, I'll give 1 point. Right, Nana? Strength of the bond. Strength of the bond is depends on extent of overlapping. Strength of the bond. So, is directly proportional to extent of overlap. Strength of the bond directly proportional to extent of overlapping. Here, end-to-end overlapping is more strong than axial or lateral overlapping. End-to-end. Right, extent of overlapping will be impact will be more compared to sideways overlapping. You just imagine two buses collide opposite to each other, end to end. Many people will take permanent tickets. If two buses overlap like this, overlap means they dash like this sideways, damage will be less. Just imagine same thing in case of orbitals also. End-to-end overlapping is face-to-face overlapping. It is more effective than sideways overlapping. Sideways overlapping means like this. Is like this. Okay. So sigma bond is strong bond. Pi bond is weak bond. And every time axial overlapping takes place first. After axial overlapping only lateral overlapping takes place. Next. So lateral overlapping is pi bond, forms pi bond, here sigma bond. Next one, nature of overlapping. Nature of atomic orbitals also affect the strength of the bond. PP axial overlapping is more effective than SP, then SS, and last one is PP lateral overlapping. This is the order. Lateral overlapping. Decreasing order of overlapping. Next, nature of the shells. Nature of the shells means subshells I told you no, or orbitals I told you no. PP, SP, SS. Last one is PP lateral overlapping. Here, nature of the shells, shell number. First shell, second shell, first shell, second shell, like that. We'll see the order. Nature of the shells. Overlapping is also depends on nature of the shells. 1-1 overlapping is greater than 1-2, greater than 2. Means first shell of one atom overlapping with first shell of one atom. Overlapping will be more because atoms are small, no? Overlapping will be more effective and strong bond will be formed. 2, 2, 2, 3, like this. Decrease. That is the reason small molecules are stronger than larger molecules. Here there is one exception, students. Bond dissociation energy of fluorine is less than chlorine. Actually, fluorine bond dissociation energy should be more. What is bond dissociation energy, students? Energy required to break the bond between two atoms in a molecule. Here, fluorine, since its size is small, 2-2 bond energy is stronger. 2-2 bond is stronger than 2-3 I said, no, 3-3 I said, no. But here it is exception. Chlorine needs more bond dissociation energy than fluorine. The rest will follow same order. As the bond length increases, bond energy decreases. But fluorine bond energy is less than chlorine. Reason is here, fluorine is very small and it is carrying 3 lone pair of electrons. Chlorine also carrying same number of electrons. Since it is large, lone pair of electrons little far away from each other. It can retain the lone pair of electrons. Here, small size, more electron density. More electron density. So repulsions between lone pair, bond pair, and lone pairs will be there. So molecule lose its stability. Molecule lose its stability. Here, chlorine, it is not very small and it is not very big also. It is comfortable to retain lone pair of electrons to manage the repulsions. So Cl2 molecule bond energies. If you go to bromine, iodine, again bond length factor will plays major role. And as bond length increases, bond energy decreases, larger size. Only in case of fluorine and chlorine, chlorine bond dissociation energy is more than fluorine. Reason is high electron density, small size and more electron density over fluorine. So easily this bond will break. This is one exception. Bond dissociation energy. Better to write complete sentence. BD, bond dissociation energy. Nature of shells. Then students, differences between sigma and pi bond. Do you know, students? Many things we learned here only, now only. Can tell all those things. Sigma bond and pi bond. Now this one is strong bond. No, before that I'll try to. It is formed by axial overlapping. Formed by lateral overlapping. This one is strong because axial overlapping is more effective. This one is weak compared to sigma bond. It is independent bond because without pi bond, sigma bond can exist, but without sigma bond, no pi bond. Because after forming pi bond, sigma bond only pi bond will form. So this is independent bond. It can exist independently. Depends on sigma bond. Here, electrons are existing in cylindrical symmetry. Here, saucer type symmetry. Symmetry. These differences enough. Next side heading, hybridization students. Hybridization. I think this you don't know. Hybridization. Do you know, students, hybridization? This topic converts everything new for you. Hybridization. Till here you might have learned. Important concept. Hybridization. So if I start also now, definition also I can't finish explanation. Next class I'll continue. Hybridization separately we will.